and welcome everyone. We've got the standard disclaimers. We need those, but fairly informal presentation. I've turned things around a bit and talking about, I guess, the lower tier projects before we get into Lynn Lake. But we've got 3 high quality projects that could be a lead project for any junior exploration company. And I think one of the questions was how can you justify your expenditure and where you're putting it and things like that. So I think I'll address those kind of questions as we go through. Lynn Lake, big nickel sulphide resources, but also been described as the best brownfields exploration play for nickel sulphide in North America, and we still maintain that assumption. Miriam, a new project in our backyard at Kilgardy, Western Australia, nickel sulphide, but also more recently spodumene in pegmatite sticking out of the ground. And Mt Gilmore, a slow burn on that one, but potentially a game-changing kind of asset that's prospective for large, intrusive porphyry copper type systems. So I'll go through and talk about Mt Gilmore to start with. We've been involved in Mt Gilmore since probably about 2016, and we picked it up for a small little cobalt sulphide deposit, very unique and rare kind of system. But our work regionally has identified the potential for something much larger. And when we first got Mt Gilmore, there were a lot of little copper prospects all the way up the full 20k strikes length of that project area. Our surface geochemistry, which is what this image is copper in soil. Our surface geochemistry really tied all these small prospects together into one big or a couple of big type of systems. So that's where we work. We struggled with this a bit in the early days. We saw a lot of conflicting geological information, styles of mineralization, all that kind of stuff, and it was big and it's not been drilled. So as I said, 20k strike length of anomalous geochemistry. The main center there was probably be 8 to 10 k's long, and you can see the kind of results we've had from the surface rock chip samples and all that kind of stuff. High grade copper, high grade cobalt, plus gold and silver and multiple other metals. This thing's too big to drill. We've drilled a couple of holes on the margin of it, but really, where do you drill in that 8 to 10 kilometer strike length? And so we were very cautious in saving dollars, and we also didn't fully understand the model. So we come across this thing called green rock vectoring, developed by the University of Tasmania. CODES at the University of Tasmania is an organisation within that university that's really sponsored by industry. A lot of the major companies invest in this, and they've invented or developed a system where they believe they can vector in on a heat source of these styles of deposits. And so we gave that a shot. A lot of it's still confidential, that they won't even explain to us, but we understand the science behind it. They gave it a shot, and we had the first pass work we announced last year. It was interrupted by COVID, of course, but that work told us that without a doubt, what we see in the surface at Mt Gilmore is sitting on top of a large to joint porphyry copper deposit. So this is a big mineralized system they're talking about. So this next phase of sampling that we're doing, we hope we get enough samples in the right place and the right type of samples where they can vector in on the heat source or heat sources of this hydrothermal system for us to consider drilling. So it's a low cost for us to maintain Mt Gilmore. We think the potential benefit of something being there is quite large. A lot of other companies have looked at this asset, but it's really not until this recent work by CODES where I guess the full potential of Mt Gilmore has been identified. So we're quite excited about it. It's slow in that we're dealing with the university. They have different timelines. I think in COVID, a lot of these scientists and researchers were locked up. They're all out about the earth at the moment looking at different deposits, but we had hoped to have this next phase of sampling finished this quarter. It hasn't been completed. We've been promised shortly. So as soon as we get information on when those samples will be available, we'll let the market know. Miriam, a new acquisition. Leases have just been granted. We acquired Miriam for the Miriam nickel sulphide deposit. It's a 1969 discovery of nickel sulphide. High tenor of nickel in disseminated and net textured style sulphide mineralization. Not a lot of massive, small zones are massive, but smoke for the full length of the Miriam trend, which we identify as about 2.5 kilometers in length. More recently, we've discovered spodumene pegmatite sticking out of the ground here, and we've had to announce that. As a lot of you are aware, lithium is a very hot commodity at the moment, and we couldn't go without announcing that to the market. But the main focus of this project still is the nickel sulphide mineralisation we have. We just completed high power ground EM over that Miriam trend, and the Miriam trend is on the basal contact. This is ultramafic, that's mafic country rocks, and the Miriam trend is on the contact here of the ultramafic with the underlying units. The EM told us without doubt that historically this kind of survey would not have worked. There's large barren sulphide bodies sitting in the footwall in the underlying mafic rocks that really mask any geophysical signature you could have got from the electromagnetics. And some of the old reports talk about the conductance increasing at depth as they approach the basal contact of the ultramafic. This is because they're actually drilling towards these barren sulfides sitting just off the contact. So we've gone back, reprocessed a lot of the downhole geophysics that were completed in the past, and really focused on the more subtle anomalies for drill testing. In addition to that, we've done detailed ground magnetics and detailed ground gravity. The ground magnetics is to help us nail down that contact with more detail, and the ground gravity is so that we can really have a look at the weathering profile, and with the theory being that if a sulfide body exists, it weathers more easily, more deeply than the surrounding rocks, and we're looking for depressions in that contact zone. So that's the fieldwork for that has been completed. We're now processing the data, and again, this is all in the attempt to get our programs of work in and approved as soon as we can. We have identified major channels in Miriam, but there is really nickel sulphide for the full length of the Miriam trend within our project area, and a lot of this drilling didn't intersect the basal contact. So we're picking up clouds of sulphide around that contact. So it's a hot project, fair bit of work to do, and drilling is really the only thing that will tell us what we've got at Miriam. So hopefully, if we can get our programs of work in the next couple of weeks, that we can get a fast turnaround on that for drilling. The lithium, we announced that we'd done some rock chip samples. We put those samples in for an assay. These were weathered or partially weathered samples. We've got up to about 1.85 lithium dioxide in partially weathered rock. So that's quite good, because the lithium in spodumene is very mobile. So as soon as it weathers, the lithium just disappears into the environment and surrounding rocks. So 1.85 we thought was quite good. We've since gone back there and got a lot more samples, and we've taken soil samples as well, detailed soil sampling program. And that's given us a footprint of about 1.6 kilometres for that main trend where we saw the outcrop. It's quite wide, about 300 metres wide, and we do see pegmatitic float all over that area. So we don't believe that that's one big pegmatite. We think there's probably multiple zones within that width. To the northwest, we see another trend. It's more east-west. Why it's interrupted here, we're just hypothesizing, but there is a waste dump from this gold operation sitting in there, and I guess the material from that waste dump is traveling that way down slope. So, but it's actually trending east-west. It's a slightly different pegmatite, but of course, as you can see by this geochemical image, it does contain lithium. So again, with this work, and we've done some gravity over this as well, we'll be submitting a drill proposal for Miriam to include drilling the pegmatite, drilling the targets within the nickel sulphide targets within the Miriam trend. And we'll probably put a couple of holes into a gold deposit that we have in that ground as well, called the forest gold deposit. It's been drilled some quite high grade intercepts in quartz lodes within an ultramafic rock, and only 2 or 3 holes have actually hit fresh rock. So that's an interesting little thing. So yeah, a bit of a solid work program coming up for Miriam with respect to nickel and lithium. Lynn Lake, this is the main one. A lot of you know about Lynn Lake. A lot of the questions we've received online are all about Lynn Lake. Great infrastructure, township built for the mine back in the 50s. 2 hydropower stations that run not only Lynn Lake but the district. A rail link to Lynn Lake where the ore used to go out, the concentrate used to be transported out historically. And also road access to Thompson, just down here, about 300 k's away. That's a major Vale nickel mining centre. And once you get to Thompson, really you have rail link to Hudson Bay up to Churchill, and all the North American rail link as well. So it's got great infrastructure for a nickel operation, being in North America, really the growth industry for lithium batteries, lithium-ion batteries, and the rechargeable battery sector, as well as Europe by ocean. Prolific producer, mined for 24 years, producing about 1 million tonnes per annum. You can see the grade there, now around the 0.8% nickel, quite low. But what we're dealing with at Lynn Lake is 100% sulphide nickel. There's no non-recoverable silicate nickel. And a lot of these deposits you get in Australia would have 0.2, 0.3% unrecoverable nickel. We don't have that. So if we're reporting a similar kind of deposit in Australia, we might be reporting 1% nickel, but really only 0.8 of that's recoverable. So what you see here is what we can recover metallurgically. And Sherrod Gordon used to own this project, plus 90% recovery for nickel, copper, and cobalt. Our project area, it's got we've got really twofold focus for Lynn Lake. One is the redevelopment of the mining centre, and the main mining centre is here, the A plug, and with the satellite L plug. So that's the mining centre, and the rest of it's exploration ground. And our main exploration focus has been the Fraser Lake complex, but we do have other plugs in the area that we know carry nickel. They've been drilled back in the 40s and the 50s, and there's plus 1% nickel in drilling there, but never been followed up really since then. So we've been mainly focused on Fraser Lake as a nickel, as an exploration front. So I'll talk about the mining centre to start with. It's where a lot of our capital is going at the moment, a lot of our attention's going. We've got large resources, large JORC resources, report about 116,000 tonnes of nickel metal at a 0.5 cutoff. And you can see the long section through the L and the A through here. Our resources are on 6 deposits. That's the purple blobs there. 6 deposits of more than 20 that have been reported in the mining centre. So quite a big system, 4 k's long. If you look at these deposits here, so the end deposit, that's 700 or 800 metres vertically. So it's these are big systems, and once you get onto them, you just need to follow them. Since mine closure, there's been quite a few mining studies and economic studies on Lynn Lake. I guess the most recent times, the most beneficial to us would have been a 2007-2008 study by Independent Nickel, a pre-feasibility study that recommended the owners go into full feasibility study. We, in 2016, did a conceptual study on mining at Lynn Lake, and those results were quite positive. But all those studies utilise historical metallurgical recoveries and concentrate grades. They use the historically accepted mining practices. And really, in the past, when this thing was being mined, the operators were basically pulling peas out of the pod, going for the high grade in a low grade system. And you can see this is one of our 2016 conceptual mine design plans you see there. That's got 243 separate stopes in 2 deposits. So it really does smack of that high grading this system adds to the cost, doesn't optimize the style of mineralization we're seeing. And that's that's the basis from where Corazon started with this operation. So we've got to really get where we think Lynn Lake's going, we've had to go back and reinvent the wheel and I guess produce a base data for us to make these assumptions going forward, because a lot of the information just doesn't exist. The current mine concept is quite simple. Historically, they produced from this Farley shaft, the haulage shaft. That was a haulage and service shaft, a big shaft. It had 2 small haulage compartments that still lifted 1 million tonnes of ore per annum. So quite a good shaft. It's all been rehabbed, but it's all still sitting there. Our concept is a bit different. We get in and do an open pit on the L plug, and this is conceptual mine design, so it's not fact, it's not real. This is a conceptual open pit, decline from that open pit, exploit the remnant mineralization sitting below the open pit there, really accessing this what we call the L drift. It's an exploration drive from the N deposit out to the L at about 2,000 foot level, accessing these deposits, the N and the O, for the remnant mineralization sitting above that. At the same time, we've refurbished the shaft as we come down here, possible another open pit and decline in the northern part, looking for remnant mineralization in these systems here, which we haven't really looked at. We know we've got a bit of high grade sitting above the A deposit out there, but we haven't done a lot of that kind of work yet. But so that's the conceptual mine design. Again, looking at green nickel, all electric vehicles. It's all hydro powered, dirt cheap energy. Lateral movement of all by conveyor belts, electric conveyor belts, or trolley assisted EVs, and really, really looking at how we can move big tonnages here. And part of that is changing the shaft around to be just a ore hoisting shaft, increasing the capacity from the 1 million tonnes per annum up to something quite substantial, and really all your services are accessed underground by the declines at either end. So that's the concept. That's where we are. A lot of the work we've been doing is looking at the bulk mining, going back to the geology, and one of the questions was what an update on the work that the Polaris, our consultants, are doing. They're looking at two things. One is the mining engineering, which I've just showed you. The other one is really analysing in detail these resources and these deposits. And what we've got here to support the bulk mining concept, this is a 1980s interpreted sketch, remembering that we inherited all paper plans and sections and things like this. So this is a cross section of the top of the O deposit, which sits here, and different rock types and sulphide shown here. So encompassing these dark lines here is what we call the amphibolite, which hosts probably plus 75% of the mineralization in the mining centre. It's a major source of ore for Lynn Lake. In that, you see these darker hatched areas. They're the highest sulphide content zones, and that's what the old-timers would have been going after, really pulling out those things. So what we're looking at and what we're saying is this thing is really well constrained on these lower grade boundaries where the amphibolite is. And in that, you have less predictable zones of high grade. Some of these are quite continuous on faults, on contacts, but other times it might be just the swirl of the magma that's dropped out the sulphides where they are. And some of the high grade bodies, could be as small as this room. Others are as big as a building type thing, So that's what we're looking at. And if you're mining these more continuous zones of high grade sulphide mineralization, you're ignoring these other sweeteners, the peas in the pod that's sitting in your low-grade material. So what we're saying, can we drop down the whole lot in a stope? Can we mine the whole lot, reducing your stoping costs and picking up all this material here? And then you look at other areas like this, less high-grade sulphide in there, but still an amphibolite and still sulphide mineralization. The funny thing is, when we put our modern science on this diagram, and this is it doesn't look exactly composited. It's composite drill hole data at about 0.6% nickel within the amphibolite. So it's a different way of looking at things. So you can see here a lot of this area here in between the stoping and etc. is all blue, and that's good mineralization. And the 0.6 is quite relevant, and I'll show you that in a minute. If we look at the stats for what we're looking here, and this is quite technical, but it gets to the basis of what we're doing, the foundation of what we're doing. This is the log probability plot of nickel within the amphibolite for the O deposit. So very specific. The waste is defined at less than 0.2. The low grade is defined at 0.2 to 0.6. And your high grade mineralization is only 0.6 and above. Okay, so this is a 1%, 0.8% type district historically mined, but your high grade is 0.6 and above. So your high grade averages 0.8 to 1%. Your low grade probably averages 0.4 to 0.5. And your waste, I don't know what that average is, but so what we're looking at is that these areas here, if we go back, this area here in the red box is actually this uninteresting area we see down here. It actually reports predominantly to the high grade domain. So that's another huge potential ore source for this O deposit. And you start to look at, I mean, that's 120 meters height there. So we're looking at more than 100 meters across here. So these are big deposits. And if we change our mining stoping methods, say from long hole stoping, which they used to do here, to something like sub level caving, instantly we drop $50 a ton in costs instantly. Now the entire processing cost is probably going to be $20 a ton. So changing our stoping method is just an instant improvement in the economics of this system. But what we do end up with is a materials handling situation. If we're going big tonnages underground, how do we get that up that shaft? And that's a major part of this study, and why we're looking at the shaft being a haulage shaft only. But we're also looking at things like ore sorting. Can we separate the waste material from the material we've mined underground at the coal face? And remembering, Lynn Lake had underground crushers when it operated. There's no reason why we can't do that again. We don't have the geotechnical information yet to say the large voids are possible to put your crushers and some of your processing down that deep, but we know that this ground is excellent with respect to geotechnical stability. So basically, your high grade and your low grade have a component of waste in it. So if we can metallurgically in the processing stream pull that out, you're taking less tons to the shaft for hoisting and you're processing less tons on the surface. So economically, a smart thing to do. You can deal with the waste underground, shoving it into open voids and things like that. This work is well advanced. We're moving to bulk testing on a number of methods. The key for those would be ore sorting. We're doing with Steinert in Perth, and also HPGR, that's high pressure grinding rollers. That's a way of crushing it. And it's only really been, I guess, developed since the mid 2000s, maybe. So quite new technology, but very efficient, low energy usage, etc. And so what you do, you grind the rock to 1 or 2 mils, and you do the coarse float on it. Both the bench scale test works for ore sorting and coarse flotation have been very, very successful. We're moving to bulk test work on that. This metallurgical test work should all be finished by May. With respect to the resources, we need to redo in Lynn Lake. The timelines there are really depending on personnel. We've got a small but very, I guess, best practice team involved. And so we're looking at doing the resources as we can get these things done, doing the mining studies on a project by project basis. And really, we're probably looking at the end of July before we can complete the resource work. So some of the mining studies will have to be post this financial year into the next financial year. And I guess if we're looking at completing a scoping study, we're moving things in parallel as much as we can, but we hope it's going to be the end of the third quarter or early the first quarter of this year. But they're my rough schedules. The consultants have to come back with detail on that, but that's a wish. We're trying to shorten those timelines as much as we can and offset work from key personnel to other personnel, and it's just an ongoing basis of optimizing our resources. But just say it's a major focus for the company. It's not a huge cash burn for that, but it just takes time. With respect to exploration, you'd see in our announcements that we really still are focused on Fraser Lake. We've hit a lot of mineralization at Fraser Lake, and what the recent drilling in the mining centre has told us that you do not have to go very far from these deposits to see no indication of sulphide mineralization. You can drill right beside. You can be 1 metre off these things and not even notice any mineralization. In fact, you can drill through the main resources in the mining centre, and there's a 75% chance you will hit low grade or waste and not even know you're in a deposit. So that's what we're dealing with. So when we look at what we've done at Fraser Lake, we've done a lot of geophysics. It's quite a difficult place to explore, but we've also hit a lot of sulphide mineralization. The best sulphide mineralization we've hit in drilling, really, if you look at a geophysical method that matches that, would be induced polarization, IP. The IP we have over Fraser Lake is old school 2D, low powered, and really we can do so much more of it. The reason we've held this off until I guess now is because of cash. It's quite expensive to do these kind of surveys, but we've bitten the bullet. Our first area of interest, I think it was costed up about $600,000. We said, oops, we can't do that. So we pulled it back to a smaller area, and it's going to cost us $200,000 or $300,000 to do. That field work is completed. It's a big survey and produces lots of data. The processing time for our survey is anywhere between 4 weeks and 8 weeks. So they finished the survey. We've got some of the data. We're working in the background in two dimensions on this data, but the 3D processing, I think, is going to take a month and a half. So once we have that information, we'll be able to dive straight into it on the work we're doing on 2D, look at the 3D and really targeted drilling. And we hope by mid-year that we will come up with some fairly compelling targets in Fraser Lake for drilling. And being summer, it's not the easiest place to drill, but if we have some of our targets in areas we can drill, we won't hesitate to get in there and do a drill program in summer. Okay. Right, so that's us. 3 very good projects. We do rank our projects, of course, and that's our major investors, being Delphi and Blackstone. Blackstone very interested in concentrate from Lynn Lake. We've had a number of inquiries from big companies over the years on Lynn Lake, but I think it's up to us to really as it usually is in small companies, to really solve the problems associated with these type of systems and really optimize Lynn Lake and then present it to everyone on a platter. We think there's a good opportunity that Lynn Lake can be a long life, low cost green nickel project. If we report 16 million tonnes at a 0.5 cut. If we can justify lowering that cut to say 0.4, suddenly we're closer to 30 million tonnes in our resource. So we are talking about a serious long life project. When considering it produced about 1 million tonnes per annum previously. We hope to be able to double that. We just don't know yet. So that's where Lynn Lake is. But a lot of our investors, like our including Blackstone and Delphi, they're also there for the 10-bagger. We are valued on the market as an exploration company. There's no doubt about it. We get no value for our resources at Lynn Lake or this redevelopment work. So exploration is critical in the background or as a focus in some projects to continue looking for that 10-bagger. And Lynn Lake is a major exploration play for us. It's at Fraser Lake, we have the opportunity to discover a whole new mining centre out there. And that's the size of the thing we're looking at. How do we get from $10 or $15 million market cap to be a company that can justify raising a couple of $100 million for the redevelopment of Lynn Lake? I guess the way we look at it is the value of these green sulphide nickel projects, and that they're becoming rarer and rarer and higher value. And it'll get to a stage, if it's not already, where people that want this nickel will just come and buy the asset, buy the metal in the ground, and it's going to be the way these things are progressed. There's already groups out there that have approached us, funds and government bodies, saying, okay, if you get to this point, being feasibility study or whatever, that we're here for you when you get there. So there's that interest at this level, at a high level in these projects all over the world for all companies that own them. So don't worry, if the project's good enough, the money will be there. So in the meantime, please watch our announcements on exploration and results. We're pushing as hard as we can on all the deposits, all the projects, and hopefully we can deliver news throughout the year. So thank you very much.